I am R. Born Vignesh. My roll number is 23VV1A1244. Now I want to explain some problems in computer networks. So the first problem is it is desired to send a sequence of computer screen images over an optical fiber. The screen is 3840 into 2160 pixels, each pixel being 24 bits. There are 60 screen images per second. What data rate is needed? Pixels per frame is equals to 3840 into 2160 is equals to 8.29 million. Each pixel is equals to 24 bits. So one frame is equals to 199 MB. At 60 frames per second, 12 Gbps. So the answer is 12 Gbps. Explanation. The huge resolution and frame rate require a very high data rate close to 12 Gbps. Coming to the second problem. Television channels are 6 MHz wide. How many bits per second can be sent if 4 level digital signals are used? Assume a noiseless channel. Here we need to use Nyquist formula. C is equals to 2b log m to the base 2. Here b is equals to 6 MHz, m is equals to 4. So C is equals to substituting these values 2 into 6 into log 4 to the base 2. So 12 into 2 is equals to 24 Mbps. Explanation. With 4 level signaling, 2 bits per symbol and no noise, the maximum capacity is 24 Mbps. Now coming to the third problem. If a binary signal is sent over a 3 kHz channel whose signal to noise ratio is 20 dB, what the maximum achievable data rate? What is the maximum achievable data rate? SNR is equals to 20 dB is equals to 100 linear. Shannon formula. C is equals to B log 1 plus SNR to the base 2. So C is equals to substituting these values 3000 into log 1 to the base 2 is equals to 20 kbps. Explanation. The noise restricts the capacity, limiting the maximum to about 20 kbps despite binary signaling. Now coming to the next problem. 10 signals, each requiring 4000 Hz, are multiplexed into a single channel using FTM. What is the minimum bandwidth required for the multiplexed channel? Assume that the guard bands are 400 Hz wide. First we need to consider signals is equals to 10 into 4000 is equals to 40 kHz. Guard bands is equals to 9 into 400 is equals to 3.6 kHz. Total 43.6 kHz. 40 plus 3.6 is equals to 43.6 kHz. Explanation. The guard bands ensure separation, slightly increasing the required total bandwidth. Coming to the next question. Why was the PCN sampling time being set at 125 microseconds? Nyquist says greater than or equal to 8 kHz sampling for 4 kHz voice. 1 by 8000 seconds is equals to 125 microseconds per sample. Explanation. This ensures accurate reconstruction of voice without aliasing. Coming to the next question. What signal to noise ratio is needed to put a T1 carrier on a 1 MHz line? First we need to take C is equals to 1.544 Mbps, B is equals to 1 MHz, SNR is equals to 2 power C by B minus 1. SNR is equals to 2 power 1.544 minus 1. So we need to substitute this C value. The value is approximately equal to 1.916 is approximately equal to 2.82 dB. Explanation. Only a modest SNR is required since the capacity needed is close to the bandwidth. Now coming to the seventh problem. A cable TV system has 100 commercial channels, all of them alternating programs with advertising. This is more like TDM or like FTM. We have to say is this like TDM or like FTM? It is FTM. Each TV channel has its own frequency band. Explanation. Time alteration of ads programs is unrelated. The channels are separated by frequency. Now coming to the last problem, which is eighth problem. A cable company decides to provide internet access over cable in a neighborhood consisting of 5000 houses. The company uses a coaxial cable and spectrum allocation allowing 100 Mbps downstream bandwidth per cable. To attract customers, the company decides to guarantee at least 3 Mbps downstream bandwidth to each house at any time. Describe what the cable company needs to do to provide this guarantee. we need to describe what the cable company needs to do to provide this guarantee. So the answer is total demand is equals to 5000 into 2 Mbps is equals to 10 Gbps. Each coax provides 100 Mbps. So at most 50 ohms per coax. Thus, greater than or equal to 100 segments are required, each serving less than or equal to 50 houses. Explanation. By splitting the network into smaller service groups or using channel bonding, the company can ensure each home always gets at least 2 Mbps. So this is the explanation for 8 problems. Thank you.